So the third step in the metallurgy, the fourth step or third step, whatever. So the next step we completed the in the extraction of metals from ore, concentration of ore completed, conversion of concentrated ore into metal completed, then refining or purification. Refining or purification of impure metal. Impure metal. Till we did not get the pure metal, right? Then refining of metals. The process of purification. The process of purification of impure metals. The process of purification of impure metals. Impure metals is called as refining. So the metal prepared by the various reduction process, like various reduction process. So usually contains little percentage of small impurities. So to make the metal pure, we need to remove the small impurities also. So that process we can call as the refining of metals. Refining of metals or the purification of the crude metal. So for example, the copper obtained from its ore, a compound of iron, copper iron pyrites, CuFeS2, contains some more copper sulfide, iron and sulfur. It is purified by suitable methods, including electrolysis. The process including for example, copper pyrites, CuFeS is a copper iron pyrites. So after reduction process, still it has CuO2S as and iron and sulfur. So some impurities also present. Contains some copper sulfide, iron and sulfide as the impurities. So to remove this small impurities from the metal, from the crude metal, so we can use process. There are different processes. I already mentioned in flow chart. What is the distillation? The first one is the distillation, polling, liquefaction and electrolysis. By using these four methods, we can refine the crude metal. So distillation, polling and electrolysis. Let us discuss about this. First of all, distillation. This method is useful for purification of low boiling metals like zinc and mercury containing high boiling metals as impurities. The extracted metal in the mortars is distilled to obtain to pure metal as distillate. So this distillation is a separating process used to separate the substances from based on their boiling points. So distillation. So this is used to extract the metals like zinc and mercury. They have low boiling points, and the impurities also maybe have high boiling points. So the crude metal in the form of liquid or molten state. So heated, then what will happen? Low boiling metals are obtained. Then by polling. So based on the boiling points, distillation, polling. the molten metal is stirred with the logs of green wood. The impurities are removed either as gases or they get oxidized and form slag, scum over the surface of the molten metal. So, for example, if you take a molten metal is stirred with logs by using some logs. When we stir it, then what will happen here? These impurities are removed by gases or they get oxidized and form slag over the surface of the molten metal. So above there is they form some slag. Waste metal is formed above the metal. So blister copper is purified. Blister copper nothing but is CuFeS. Blister copper is obtained from CuFeS, copper iron varieties. Blister copper is purified by this method. The reducing gases evolved from the wood prevent the oxidation of copper. So this is the method polling. So by using polling, in the polling method, the molten metal is stirred with the wooden logs, green wooden logs. Some gases is formed around it. In the impurity present, they form above the metal. So then we get pure metal. Then liquefaction. In this method, low melting metal like tin can be made to flow on a slopy surface to separate it from high melting impurities. So to purify the low melting metals like iron, this liquefaction method is used. So when we flow the slopy surface, high melting and low melting, high melting impurities are removed and low melting metals are obtained. So these are the three methods. Then coming to electrolysis. Electrolytic refining. So here we can write electrolytic refining. So by the process of electrolytic refining, we can purify the crude metal. So the most important and most widely used method, method for refining impure metal is electrolytic refining. This is described. Some important points. Electrolytic refining means by the process of electrolysis, we can get a pure metal from impure metal. So as you have an idea about electroplating, similarly electrolysis also carried out. Many metals like copper, zinc, iron, lead, tin, chromium, nickel, silver and gold are refined electrically. So for refining of an impure metal by the electrolysis process, a thick block of impure metal, made as a anode. Then a thick block a thin strip, sorry, a thin strip of pure metal made as cathode, and we have a suitable electrolyte, a water soluble salt solution. So used as a electrolyte. Is taken as electrolyte. So electrolyte is a substance or the liquid substance or the molten state of substance which allow the electric current. So these are the three important terms. A thick block of impure metal made as a anode, a thin strip of pure metal made as a cathode, a water soluble salt solution taken as an electrolyte. On passing electric current, impure metal dissolves from the anode and goes into the electrolyte solution, and pure metal form on the electrolyte deposits on the cathode. The soluble impurities present in the impure metal go into the solution, whereas the insoluble impurities settle down at the bottom of the anode as anode mud. We will now take one example. So, on passing of electric current, impure metal dissolves from the anode and mixed into the electrolyte solution, and pure metal from the electrolyte deposit on the cathode. The soluble impurities present in the impure metal go to the solution, whereas insoluble impurities settle at the bottom of the anode as an anode mud. Let us take one example. Of electrolytic refining as a copper. So copper purification. Let's understand purification of copper. Right? So remaining the points carefully. So it is a thick block of, so better we have take copper copper and a thin block of copper. So here we have to take as electrolyte is copper sulfate solution. Right. Copper sulfate solution acts as an electrolyte. As we know, copper sulfate solution is an electrolyte and is a good conductor of electricity. So it is anode and it is cathode. This is copper cathode. It is also copper anode. Impure copper anode. This is pure copper cathode. Then copper sulfate solution. Copper sulfate solution. Then a cell or a battery. So electricity. Now understand the electrolytic refining. So as earlier we discussed, so the apparatus used for electrolytic solution, electrolytic refining of copper like this. So acidified copper sulfate solution used as electrolyte. As we know, copper sulfate is a good electric conductor. To increase conductivity, we have to add little amount of acidified copper sulfate solution. So to increase the conductivity of copper sulfate solution, we have to add some acid like sulfuric acid. A thick block of impure copper taken as a anode, a thin block of pure copper taken as a cathode, and we have the acidified copper sulfate solution as an electrolyte. When electricity is passed, as we know, copper sulfate dissociate and contain Cu+2 and SO4- ions. Copper sulfate contains Cu+2 and SO4- ions. On passing the electric current through copper sulfate solution, the following reactions takes place at the anode and at the cathode. At anode, one reaction takes place, at the cathode reaction takes place. So the positively charged ions from the copper sulfate solution go to the negative electrode, and by taking electrons from the cathode get reduced to copper atom. This copper atom get deposited on the cathode, giving pure copper metal. Copper atoms of impure anode lose 2 electrons each to anode and form copper ions which enter the electrolytic solution. Right. So on passing the electric current density, copper sulfate solution has Cu+2 and SO4- ions. So SO4 and these Cu+2 ions are migrate to the pure copper cathode and deposits. As we know, cathode has excess of electrons. So 2 electrons are taken by the carbon. So at cathode Cu+2 takes 2 electrons and forms copper, and and deposited on the cathode. At anode, Cu, impure copper loses 2 electrons and forms Cu+2. So Cu+2 ions from the impure copper anode dissolves in a electrolyte and forms copper sulfate. So from the impure copper Cu+2 ions are formed. Then the electrolytic solution contains Cu+2 and SO4- ions. These Cu+2 ions are migrated or transferred to the cathode by taking 2 electrons and deposited. So after copper ions taken from the copper sulfate solution at the cathode and put into the solution at the anode. As the process goes on, impure anode becomes thinner and the thinner cathode become thicker. So by depositing copper, cathode become thicker. By losing the copper ions of copper from the thicker anode, it become thinner, it become thicker. So finally what will happen? So some impurities are formed. Some impurities are formed near the anode. So these are called as anode mud. This Cu plus 2 ions are dissolved in the electrolyte. Any another impurities which are not dissolved, which are undissolved, which are non-dissolved, insoluble, for example. So the copper ions are soluble in electrolyte. The insoluble impurities are formed near the anode as a anode mud. So anode mud is nothing but impurities which are insoluble in electrolyte. In this way we get pure metal from the impure metal. So this process is called as electrolytic refining. Electrolytic refining takes place by the process of electrolysis. Right? So simple. Impure metal taken as a anode, pure metal taken as a cathode. The suitable electrolyte we have to choose by passing electricity. Electrolyte dissociate into ions. So positively charged ions are transferred to the cathode, which are impure, so deposited. Then impure metals are loses the electrons and forms ions, so it dissolves in electrolyte. So here thicker impure copper become thinner copper become thicker because of copper deposited on the cathode, where copper loses by the anode. So finally an impure substance is formed, is called as anode mud. Then this way the reaction is taking place. So by the process of electrolytic refining, we get pure metal from the impure metal. So what happens to the metallic impurities present in the impure which is being refined? The metallic impurities present in impure copper can neither be more reactive or less reactive. More reactive metals like iron present in the impure copper pass into electrolytic solution and remain there. On the other hand, the less reactive metals like gold and silver present in the impure copper collect at the bottom of the electrolytic cell below the anode in the form of anode mud. So metal also has the impurities. If they are the highly reactive, they passes through electrolyte. If they are less reactive, they are formed as impurities in the electrolytic cell. The setup is called as electrolytic cell, formed as impure substances as anode mud. So this is about the purification of metals from pure metals. Then gold and silver metals can be recovered from the anode mud. Thus electrolytic refining of metals serves two purposes. One is refines the metal and enable to recover the valuable metals present as impurities in the metal being refined. So this is electrolytic refining for two purposes. One is it purifies the metal concentrated, and any valuable impurities, any valuable metals are as a anode mud, as a impurities also have to collect from the anode mud. So this is about the extraction, metallurgy, concentration of ore, getting crude metal, then getting pure metal. So then the next session, then we will discuss another important one, corrosion and alloys. So thank you so much. Sign off.